Do you think we can do it? I hope so. I'm certainly going to give it a try. Today, I'd like to complete the design and layout of the printed circuit board that we've been designing for our variable intensity high power LED driver. We've been building this for about 22 episodes or so, and if you haven't seen the previous episodes, look in the description. There is a link to the journey, which I encourage you to take a look at. But if you have been watching, then you'll know for the past 4 episodes or so, we've been laying out this printed circuit board design. Today, we're going to finish it up and send it off for manufacture, so that way the next episode it'll be here in our hands and we can actually start building this circuit. Oh, I've been waiting for this for such a long time. We've got a lot to do. Let's get to it. Here's our fancy block diagram. Back in episode 18, we started off by designing and laying out the optional indicator portion of our printed circuit board. Then in episode 19, we moved on and laid out the logic components. In episode 20, we laid out both of the buttons and the rotary option. If you remember, our variable intensity is going to be controlled either by buttons, which you can press up or down, or it's going to be a rotary where you turn the dial and increase or decrease the intensity. Then in episode 21, we wanted to start laying out these drivers. Then we ran into a problem. We found a short circuit. So rather than doing that on episode 21, we focused on building short circuit protection into the LED drivers, and we augmented the circuit to make that a reality. So now in episode 22, we're going to start laying out these drivers. Let's get started by looking at the circuit, or the updated circuit of the LED driver. And here it be. Here's the updated circuit schematic diagram for our LED driver. There's that Zener diode, which is going to measure the voltage and capture if we're actually in a short circuit state. And then of course, all the circuitry that goes along with that short circuit. And there is the indicator that lets us know we are in a short circuit. And of course, the rest of the componentry over here gives us our constant current driver so that we can maintain a constant illumination on that LED. And of course, the level of illumination is controlled digitally by these data inputs. Now, while this schematic shows 5 data inputs, in reality, we're going to design that circuit board so we can actually implement anywhere from 4 to 6 data inputs. And if you do the math, the 4-bit driver gives us 16 intensity or levels of intensity of brightness. The 5-bit driver is going to give us 32 levels of intensity of brightness. And the 6-bit driver is going to give us 64 levels of intensity. Looking back at the block diagram, we can see that we wanted to include lots of drivers. And this makes sense because each driver is only going to have a limited maximum output of light. And in order to make more light or to illuminate a bigger room, we need to have more drivers in that room. And so early on, we decided that all of this stuff, the indicator, logic, buttons, and rotary, will exist on one printed circuit board, and the driver will exist on a separate printed circuit board. That way we can add as many drivers as we need. So how are we going to add multiple drivers to the same board? Well, I happen to have these cool things right here. I found these a while ago, and basically they're just, this is a string of connectors which you can actually break apart so you can get smaller I guess pin counts on them. But the really neat thing about these is that they'll stack upon one another. Take a look. So here's 2 connectors, each one of them having 2 pins each. I've basically just took that long string of connectors and cut these 2 pieces off of it. Now the cool thing is these will actually connect to one another and stack. So if I do this, they're now connected and I can keep going. Look, I can add another one on top and just keep stacking these things up. So we're going to go ahead and use these to connect multiple drivers to a single logic board. So the first thing we're going to do is lay out the input pins for the power and ground and our data lines coming in. And here they are. These 2 will serve as the power and ground, and these inputs over here, these 6 inputs, will serve as our data pins. As we recall, not all 6 will always be used, so I laid them out in this interesting fashion where these 4 will always be used, and these are 5 and 6 optional data bits depending on how we want to implement the driver. Each of those data lines are connected to these diodes over here and to the base or the gate of these MOSFETs. Let's lay those out. Here they are. Here's the diodes over here. All the traces are connected, and they're also connected to the gates of all of these MOSFETs that we included. You'll also notice I popped in another resistor over here. This is the OR resistor right over here. Then I can put in all the rest of these components over here, including the Zener diode and all of the other MOSFETs and BJT transistors. There they are, all populated and laid out on the board. Now I'm going to add in this indicator LED that lets us know that we're in a short circuit. And there's the footprint for the indicator diode with the traces all connected to the appropriate components. Next, I'm going to add these resistors in to the circuit. And here we can see all the resistors laid out and the traces connecting them. You're probably noticing that the traces are thicker than the other traces. That's deliberate. These resistors are where all the current is going to be flying through, the power current that's going to be illuminating our LEDs. And I do not want any trace to be restricting any of the current flow, giving us some stray resistance within our circuit. So in order to prevent that, I tried to make them as fat as I possibly could while still keeping the size of this board fairly small. The other thing you'll notice is that there's a whole lot more resistors here than there is in the circuit diagram. And I also did this deliberately. I've actually laid out room so that each resistor in our schematic over here corresponds with two resistor footprints over here. And the reason I've done that is because the specific values of resistors that we're going to be using for these drivers are very precise. And it might be easier to create some of those high precision numbers using two values or two resistor values in parallel. Now I'm going to add in the LED connectors over here. Now these two connectors on the PCB are going to lead to the actual LEDs that we're going to mount wherever they happen to be mounted to. And here's the connection over here. And just like before, you can see the nice fat trace that I put in here because all of that current is going to be flowing through that trace. And finally, this big space in the middle is reserved for our big beefy power MOSFET. This one right over here. As we've discovered, as we've been building through this LED driver, this power MOSFET might get warm. This is where the excess energy is going to be burnt off that's not being used to light up the LEDs. We need to have it in here, and we also need to give it lots of space to help dissipate some of that heat. And so there's the footprint for the big beefy MOSFET. There's our three leads at the bottom, the gate, the drain, and the source, and we have this giant pad up here with the hole in the center. The reason I'm putting that in is because if you remember, we've been using the BUZ71 MOSFET so far, and that thing has a giant heatsink with a hole for a screw. So I wanted to leave that onto the board in case we continue to use that. Little bit of a spoiler alert, I've scoped out another power MOSFET that I'd like to use for this, and that power MOSFET doesn't actually have a screw, but it does have a heatsink. So we do need to add a little bit more to this, hence why there's some space in the middle here. But before we do that, let's make sure that we connect the traces for all the leads. So here are some of the traces. Here's the gate and the source. And here's the big power trace. This is the drain of that MOSFET, and you can see this giant blue trace leading out to where the LEDs are coming. So now it becomes a little bit clearer as to where all the power is going to be running in this circuit, down through this trace into the drain of that MOSFET. But this other power MOSFET that I have in mind, it doesn't have a screw hole, but it still has that heatsink, which of course will fit into this nice area here on this PCB and also provide a good contact so that we get some pretty good heat dissipation. But we're going to make that heat dissipation even better. Remember in the previous PCB layout videos, we talked how to use a copper pour. Well, having more copper for a component that wants to dissipate heat is very good. And so we want to try to utilize as much of this board space as possible for heat dissipation on this power MOSFET. So this board that we're using, it's a two-layer board. We have a layer at the bottom and a layer on the top. In the previous videos, we put the copper pour on the bottom layer in order to get a good ground plane. We're going to do that for this as well, but there's no reason those copper pours can only be on the bottom layer. I'm going to put in a copper pour on the top layer just to give us even more copper so we get better heat distribution. Take a look. So just like the copper pour on the bottom, the first thing we do is we create a little outline, and notice this outline is green because that green means it's going to be on the top layer. So this is the green outline, and see how it's kind of connected here to this drain? Remember, the heatsink on these MOSFETs is electrically connected to the drain of the actual MOSFET. So I want to make sure they're connected on the PCB as well. So that's why you see this outline overlapping with this little nub here, which is connected to the drain pin. Now let's fill it in. And so there it is. There is the shape all filled in for our copper pour, and it's electrically connected to the circular pad and to the square pad. And this whole thing is the drain of the MOSFET. So this is on the top layer of our board. Let's put the same thing on the bottom layer. So I've hidden the top copper and the top solder mask, so the green just goes away. And you can see the outline that I've also created for the bottom layer. And I'm going to do the exact same thing here as I'm going to do a copper pour for this bottom layer. And there it is. This is the bottom layer copper pour for the drain of our big beefy power MOSFET. So I also wanted to add a copper pour for the ground plane, and we can see it here. I took my time in creating this because there's not a lot of room to work with in this on this board, so I really had to pay attention as to where I can put this copper pour. So the outline looks complicated, but it was necessary for me to make sure that all the ground pins are connected, electrically connected, ground pads, sorry, and I wanted to cover as much of the board as I possibly could. So there is my ground plane, which I will pour and fill in right now. All filled in and looking nice. And when I add the top layer back in, it looks like our board is complete. Now let's take this and make sure that it fits on our primary board. As you might expect, I've already done a little bit of pre-planning when it comes to laying out these boards. I mean, take a look. Here's the board as we left it last time. You can see the indicator LEDs are all along the right side over here. Near the bottom, we have all the logic components that are already designed. We also put in our up-down buttons and our rotary controller. If you're interested, go back to some of the previous episodes to watch how we laid this out. And you'll notice there's still quite a bit of space. Deliberate. There's enough space on this board to add 2 of our LED drivers. One will fit nicely into this space, another will fit nicely into this space. The first thing I'm going to do is make some room. So this is the power line that's coming in from the plus 12 volt in. I'm just going to remove that and get it out of the way for now. And in this clear zone, I'm going to put in the footprint for our LED driver connectors. These connectors should look familiar. You saw them earlier on the driver, and you can clearly see that there's 2, one over here and one over here. Let's wire them up. The first traces I've added are the data lines. So these are the data lines from 0 all the way to 5, so the 6 data lines. I put them all on the second layer of this board. Now, because we have 2 drivers, I want to make sure that the data lines that show up on this driver also show up on this driver. And there they are. I've decided to put this on the top layer of the board. So these traces will effectively connect our LED drivers to the components, but there's something that you may have forgotten. In fact, I forgot it when I was laying this out. But if I highlight the nets for data 0, you can see data 0 is flashing. You can clearly see that both the drivers are connected to one another, and they're also connected to the circuitry on the left side. But it's not connected to the circuitry on the right side. This was deliberate. I had forgotten that I did this, but I deliberately left that out because I'm going to route them now. So I need to connect all of these data lines that are disconnected from the left side and the right side. So let's put in a few more traces to get all those connected. And there they are. These traces, I managed to put them up on the top layer. And if I highlight those data lines again, now you can see that they are in fact connected all the way through across the entire board. So the next thing I'm going to do is connect the power, the plus 12 volts to our drivers. And I'm going to make a little change over here just because the layout with these power traces over here I wasn't too happy with. So just take a look and see what I've done. I've reorganized it so that the power trace is a little bit smoother, but I still do have a power trace coming up to this this up indicator LED. But it for me it looked better. So I wanted to connect it this way. And now we can go ahead and connect the LED driver power to our power in. Notice I've used a very fat trace to connect this because the bulk of the current is going to be going straight from this input to that LED driver, or the stack of LED drivers, I should say. And now I can do the same thing on the other side. I want that power to be connected to the 12 volt net. So now we have it connected and connected to the 12 volt in as well. So now if I look at all the 12 volts, it's properly connected throughout the entire circuit. And the last thing to do is our ground plane. So let's make the outline. There it is on the second layer. You can see it highlighted in blue. This one is much easier than the driver. And then I'm going to go ahead and do the copper pour. Done. There's our beautiful ground plane done on the second layer of this board. So that's it. Our printed circuit board is designed and laid out. We have a logic board and we have driver boards. We have to take both of these boards and send it off to manufacture. Now, most manufacturers are going to require something from you. And the most common one that I've seen is this thing called a Gerber file or a Gerber file. I actually don't know how to pronounce it, but you'll see it in the software. Now, depending on the software you're using, the process to create those Gerber files or Gerber files might be different. Let me show you how I do it in this one. So once you've completed your design, there's an output function on this particular software where I'm allowed to select manufacturing plots. And it's pretty straightforward. You pick all the different layers that you want. I am not going to get any top copper paste or bottom copper paste for my designs. If you don't know what that is, don't worry about it. We're not using it. All I wanted to make sure I have top copper. I have the top solder mask. I want the silk screen, which is the printing on that, all the words that we put onto our board. I also want to make sure we got bottom copper, the bottom solder mask, and of course the bottom screening, silk screen, the printing that's going to be on the bottom of the board. And then these other ones are important to figure out where all the holes are going to be and the actual outline of your board. So that's why these are all checked off. Now, when you go ahead and run this, you're going to end up with a bunch of files in the output directory that are going to look something like this. And so all of these files, typically what I do is I just zip them up into a single file. You can see it over here. Notice I have two. Important because there's two boards I'm manufacturing, my controller board and my driver board. So I have to do this process twice. And these are the two files that I send off to the manufacturer. Now, in order for me to go to the next step and show you the rest of my process, there's really no easy way for me to do that without actually showing you the actual manufacturer that I used. So I was toying with it a bit in my head as to whether or not to walk through the process because I'm going to have to start naming names. I thought I'm going to go ahead with it anyway. So this is the company that I use to manufacture my boards. It's a company called PCB. They're based in China. And depending on where you are in the world, it might take some time for the actual delivery to get to you. But, if you don't need it right away, I think this is a great option. It works for me. I rarely need boards in a big rush. So when it came time to order the boards, I had to go to this portion of the website, which allows me to create an instant quote and fill in this form. Now, it looks complicated at first, but a lot of the defaults are already pre-selected for you, which makes it really, really easy. And for the most part, we can leave the defaults. I'll walk through it. I mean, we're doing a single piece board type. There's only one design in the panel. So we have to enter in the size of that. In this case, it's a 100 millimeter by 100 millimeter panel. We're going to choose a quantity that we want. I'll just choose 5. We're not going to be doing a heck of a lot. We know it's a 2-layer board, right? So I want to make sure that we ensure that this is selected as 2-layer. These ones we're just going to leave as the default. Unless you know you need to change the material, you can pretty much leave this alone. The thickness of the board, also standard, 1.6 millimeters. Leave it alone for the most part. The minimum track spacing. We discussed this way back, I think it was episode 18 or something, when we talked about how thick to make our traces. This was how I knew how thick to make those traces and how much space to leave between those traces, because this information, this form here tells me my manufacturer's limitations. Same thing for the hole size. The minimum hole size is 0.3 millimeters. The solder mask. This is the color of the board. We can pick whatever color we want on this. How about I go with red? I think I like red. Silk screen. This is the color of the printing, the text that's going to be on top of the board. I like white, so I'm going to leave that here. The edge connector, we don't have edge connectors. That means connectors on the side of the board. Not for us, so I'm going to leave that no. Surface finish, same thing. Leave it at the default. Unless you know you want something more specific, leave it there. And the via process. Basically, we haven't made use of a lot of vias in this design. We are going to make use of vias when we get to our surface mount technology. So in other words, we're going to start using the SMT chips, which actually sit on one layer of the board. That's coming up in future episodes. When we get there, we're going to start talking about vias. But just so you know, the idea of a via is how a trace can go from one layer to the other layer. There's no place for a component to sit in. It's basically just a path between layers. And so this tells me, do I want to tent them, plug them, or not cover them at all? Again, if you're ever confused about this, leave it at the default. And the finished copper. This tells us how much copper or the thickness of copper that's going to sit on the traces. 1 ounce copper is probably the most, I guess, it's the stuff I always use. If you know you need more, then certainly you can add more. Everything else is basically left the same, and then you click calculate, and it's going to give you a price. Look at that. $5. That's one of the reasons I chose this manufacturer. They're pretty cheap. To send this board or these 5 boards to me in Canada, where I'm located, it's going to be about $30 US. So not bad at all. So I guess that's it. I'm going to order the boards, wait a few days for them to arrive, and then I'll see you next time when we actually get to build this thing. And, well, see if it works.